Good afternoon. We are going to start with the solution of the problem 7, where we have a chimney made of fabrics subjected to the wind pressure and its own weight. First of all, we need to consider a cross section at a distance x from the upper side, okay? And we are going to analyze the the axial force, the bending moment, and the shear force at this cross section. Okay, in this case I prefer to isolate the upper part of the chimney and write the forces and moments in this cross section. Okay, so what we have is a weight that is 12 kilonewtons per meter, and the pressure of the wind, that is 480 newtons per square meter. Okay, we are gonna consider the area, the diameter multiplied by x. So the force per unit length is P multiplied by the outer diameter. Okay, P multiplied by the outer diameter. So we have a vertical reaction that is equal to the weight multiplied by the length, the weight density, let's say, multiplied by x, and because of this distance x and the wind pressure, we are gonna have a shear force equal to P multiplied by d2 multiplied by x. Okay. In addition, because of the equivalent force of the wind pressure is in the mid of the height x, we have to balance the moment. So we have a moment that is equal to P multiplied by d2, the force, multiplied by x divided by 2. Okay, so we have p d2 x squared divided by 2. Now, if we consider the cross section, this could be the horizontal axis. We can label it as y. The vertical axis can be labeled as z, and we can write that the normal stress in x is equal to the weight that produces compression, so minus weight force, axial force, divided by the area of the cross section plus the bending moment P d2 x squared divided by 2, everything divided by the moment of inertia about in this case about the z-axis. Okay, multiplied by y. Then if we consider that the maximum normal stress, tensile stress, is gonna be produced in x equal to d2 divided by 2, we can write that this particular value of the maximum normal stress is equal to minus the weight divided by the cross-sectional area, that is d2 divided by 2 square multiplied by number p, minus d1 divided by 2 square multiplied by number p, plus the bending moment p d2 x squared divided by 2 divided by the moment of inertia, that is d2 number p divided by 4 multiplied by d2 divided by 2 raised to the 4th power minus number p divided by 4 d1 divided by 2 raised to the 4th power multiplied by the value of this y parameter. I wrote x but is y, that is d2 divided by 2. Okay, it's not x at the beginning, it's y equal to d2 divided by 2. Okay, so we have the chimney. Okay, now this is the lower fixed support, and if we consider this the first addend, that is the effect of the weight, we have a linear increment with x. That is, if we consider the variation with x, we have this linear increment with x that is a negative stress, okay, produced in this point of y equal to d2 divided by 2. Okay, this is because of the weight. Well, and also we have the effect of the bending moment, okay, that is this addend here, okay, that produces a variation with x squared, so something like this, that we suppose that is lower than the weight, the effect is lower than the weight at the beginning, but at the end we have that this positive stress is higher than the effect of the weight. So what we need to calculate is the moment where this wind pressure, this effect of the wind pressure, rises the effect of the weight. Okay, so this distance from this point to the 0, that is this distance, is gonna be the maximum height. Okay, so let's calculate that value of the maximum height. What we are gonna do is, considering the value of the parameters, weight 12 kilonewton per meter, d2 equal to 1.2 meters, d1 equal to 0.9 meters, and the wind pressure is 0.48 kilonewton per square meter. Okay, so if we consider all these values, we can write that the normal stress in the direction x in y equal to plus d2 divided by 2, that is the point where the maximum normal stress, tensile normal stress, is produced, equals to minus 24,000 x plus 2483.4 x squared. Okay, and we have to make this equal to 0, and we obtain two solutions for x, that is x equal to 0, that is not a valid solution, and x equal to 9.66 meters. Okay, that this is gonna be the maximum height for the chimney. Okay, this maximum height we represent here. So this is x equal to 0, that is not valid, and this is x equal to the maximum height 9.66 meters.